we're going to talk a little bit about problem solving and get to know some of the things we need to know and some of what we need to know how to do. So we'll do a practice problem to think about how do we go through solving a problem, and we'll talk a little bit about some unit conversions that we need to know. So these are typical System International prefixes that you should know. So using base metric units like 1 meter, for example, you should know that there are 1,000 millimeters in 1 meter. That's how I remember it. Or you could remember there is 10 to the negative 3 meters in 1 millimeters. So however you choose to remember these doesn't really matter as long as you can remember them. So figure out a way to memorize these typical SI prefixes so that you can convert back and forth from one unit to another. We'll also go from metric units to non-metric units, but I don't expect you to have all of those memorized, but you should be able to know how to use them to convert one thing to another. So we'll start with a concept and then explore that concept with a problem. So the concept we're going to explore in this video is density. Since we'll be using density in the laboratory soon, we'll think a little bit about density. So density, here we're given D for density, M for mass, V for volume, is just the ratio of mass to volume. So we can't measure density, but we can measure mass and volume and then calculate the density of that substance. So that's what we'll do in the laboratory. So let's take a moment to think about what does the value of density tell us about a substance. Density tells us a little bit about how closely packed the atoms or molecules are. So atoms and molecules of our substance. How close are they? So to really get into thinking about that, we'll have to talk more about what an atom is and what a molecule is. So we'll save that for another video. In this video, I want to focus on example problems. So we're going to go through this one example problem that has to do with density for us to think about how we solve a problem. So first, let's read the problem together. A graduated cylinder that has a mass of 156.769 grams when empty contains 46.24 milliliters of glycerol. A gray metal sample is submerged in the glycerol, which has a density of 1.2567 grams per milliliter, raising the fluid level in the graduated cylinder to 55.70 milliliters and the mass of the cylinder and its contents to 372.894 grams. What is the metal? So that's our goal, is to answer this question, figure out what is this gray metal. So we're going to use that concept of density equals mass over volume. Since our densities are all given for our metals, if we can figure out what the density of the metal is, we can determine what its identity is. So we need to find the mass and the volume of our metal. So I'm going to start with the volume because that's easier here. The volume of our metal is going to be equal to, well, we know what the volume is after we put it in and before we put it in. So the difference between those will give us the volume of our metal. So 55.70 milliliters in this case, minus 46.24 milliliters, which is equal to 9.46 milliliters. So that is the density of our metal. The mass of our metal, well, we have several masses here to think about. So we have the mass of everything, so mass total. So to find the mass of our metal, we're going to have to take the total mass and subtract off the mass of our cylinder, right, which is given here. But we also have to subtract off the mass of the glycerol. That's not given. But we do have, so we have the mass of total, 372.894 grams, and the mass of our cylinder, 156.769 grams. how do we find the mass of the glycerol? So we're given the density of the glycerol, and we know the volume of the glycerol. We're given the density and the volume, so we could find the mass using our relationship, right? Mass of my glycerol is just going to be equal to the density of the glycerol times the volume of the glycerol. So in this case, the density is 1.2567 grams per milliliter, and the volume is 46.24 milliliters. So the mass of glycerol that was in the cylinder before we put our metal in is 58.1098 grams. So now we can determine the mass of just our metal by subtracting these two masses from our overall mass. And when we do that, we get 158.015 grams. So now we have the mass and the volume, and we can determine the density of our metal. So we have our 158.015 grams of metal divided by 9.46 milliliters of metal. And overall, we get a 16.703 grams per milliliter. So it looks like it's really close to tantalum, but we need to convert milliliters into cubic centimeters. Conveniently, 1 milliliter is equal to 1 cubic centimeter. This is a really handy conversion, especially in this case, because now I know that 16.70 grams per milliliter is the same as 16.7 grams per cubic centimeter. So tantalum must be the correct answer in this case. So this is one way to solve the problem, just walking through step by step how to solve the problem. So in the next assignment, you will get some practice walking through density problems and other straightforward problems like this one, where you can put together some ideas of problem solving and conversions.